Hello guys, welcome to another set of lessons. In our previous lesson, we introduced the concept of algorithm, and in this lesson, we are going to proceed with further concepts under algorithm. And in this lesson, we'll be looking at characteristics of algorithm. So remember, I am a computer science teacher, and my objective is to demystify your most disturbing concepts in computer science. So the lesson of today, we are looking at characteristics of algorithms. In our previous lesson, we already saw that an algorithm is a procedure for solving a problem or a step-by-step or a sequence of steps to solve a particular problem. So in this lesson, we'll be looking at the characteristics of an algorithm. For our lesson plan, we have always our same structure. We have introduction, activity, practice, exercise, conclusion. And we have assignment. So first thing, now we should note that not all written instructions for programming is an algorithm. Very important to note. And in order for some instruction to be an algorithm, it must have the following characteristics. So the characteristics are listed, and you see that for the characteristics, we have well-defined input, clear and unambiguous. It should be language independent. It should be feasible. It should be finite, and there should be well-defined output. So these 6, in summary, are the major characteristics of an algorithm. So let's look at the first one, clear and unambiguous. The algorithm should be clear, which means that it should not be complex. Unambiguous means it should not be complex. It should be clear. It should be direct to the point. The second point, each of its steps should be clear in all aspects and must lead to only one meaning. That's the meaning of clear and unambiguous. The second characteristic is well-defined input. In an algorithm, if an algorithm says to take input, it should be well-defined input. It may or may not take input. So we are saying that the algorithm should have a well-defined input, which means that you should understand the kind of input the algorithm is about to take. Finiteness. An algorithm must be finite. That is, it should terminate after a finite time. Now, which means that algorithm should not run forever. But there are some exceptions. So, feasible. The algorithm must be simple, generic, and practical, such that it can be executed with the available resources. It must not contain some future technology or anything. So we are saying that it should be feasible. An algorithm should be feasible, which means that it should be able to solve a particular problem. And of course, language independent. An algorithm design must be language independent. That is, it must be just plain instructions that can be implemented in any language. When we talk about language here, we talk about programming language independent. And yet, the output will be the same. So, we are saying that we can write an algorithm, we implement in C, we implement in Pascal, we implement in Python, we implement in Java or JavaScript. The same output should be realized. Input. An algorithm has 0 or more inputs. So, each that contains a fundamental operator must accept 0 or more inputs. So the input must be clear, and there must be something that comes into the algorithm for it to be processed, and then the output given. Output. An algorithm produces at least one output. Every instruction that contains a fundamental operator must accept 0 or more inputs. So for every input, there should be a corresponding output. And finiteness. An algorithm must terminate after a finite number of steps in all test cases. So an algorithm should not run for infinity. It should end when the steps or sequence or alterations or decisions have been implemented. It should end. Every instruction which contains a fundamental operator must be terminated within a finite amount of time. Infinite loops or recursive functions without base conditions do not possess finiteness. That is the only exception. At our level, you might not be writing such loops, but you'll see that when we'll be implementing loops, you'll see that there are times where you can write a loop and it runs until the memory of the machine is exhausted. So you see that those are loops that an extent does not end, but we don't talk about those kind of algorithms. Algorithm should execute and terminate. Effectiveness. An algorithm developed should be effective and feasible so that you can trace it out by using just paper and pencil. So we are saying that that's what about dry running. We'll be looking at dry running algorithms. You see that you can write an algorithm and you test with just pen and paper without necessarily implementing it. Properties of algorithms. The first property, it should terminate after a finite number of time, which means that after executing for a particular point, it should stop. Next, it should produce at least an output. Next, it should take 0 or more input. It should be deterministic, means giving the same output for the same input keys. And the last, every step in the algorithm must be effective. That is, every step should do the same, should do some work. So these are the properties of an algorithm. It should terminate, it should produce at least an output, it should take 0 or more input, it should be deterministic. Every step in an algorithm must be effective. So in summary, it brings us back to our diagram. The characteristics of an algorithm remain well-defined input, clear and unambiguous, language independent, feasible, finite. We have well-defined output. So this gives us a summary of the characteristics of an algorithm. For revision questions, my dear students, we are asked to state and explain the characteristics of an algorithm and outline the properties of an algorithm. If you're able to answer these questions, then you have understood the lesson properly. In our next lesson, my dear students, thanks for watching again. We are going to continue with our series of lessons in algorithm. And remember, we are here to demystify your most disturbing